Welcome to our Java programming tutorial. In this session, we will delve into the fascinating world of authenticated encryption, specifically focusing on GCM mode. GCM, or Galois/counter mode, is a popular mode of operation for symmetric key cryptography, providing both confidentiality and authenticity. Let's get started. First, let's understand the concepts involved in authenticated encryption. Authenticated encryption combines encryption and authentication, ensuring that your data stays confidential and hasn't been tampered with. This makes GCM mode a favored choice for secure communication channels. Now, you might wonder why GCM is preferred over other modes. GCM provides high performance and parallelization capabilities, which is crucial for handling large amounts of data efficiently. It also uses a simple key structure, providing robust security features, which we will explore as we go. Let's look at the basic components of GCM: the key, plaintext, associated data, and ciphertext. The key is a secret string used for encryption, while plaintext is the original data. Associated data is extra data you may want to authenticate with the same key, and ciphertext is the output which appears random to anyone who doesn't have the decryption key. Before we dive into coding, we need to ensure that we have our environment set up correctly. We're going to be using the Java cryptography architecture, which is built into Java SE. No additional libraries are necessary for basic GCM functionality. Make sure you're using at least Java 7 or higher. Now let's start coding. First, we'll create a utility class for encryption and decryption using GCM mode. The class will contain methods for encryption, decryption, and generating the secret key. In the class above, we imported necessary libraries. We then defined the GCM encryption class. We set constants such as the algorithm type, transformation string, and GCM tag length, which are crucial for our methods. The generate key method utilizes a key generator to produce a 256-bit AES key. We use AES because it's widely supported and secure. Next, let's implement the encryption method. This method will take in the plaintext to encrypt, the secret key, and any associated data we want to include. We'll also handle what is known as an initialization vector, for, which is critical for GCM mode. In the encrypt method, we first obtain a cipher instance for the specified transformation. We then create a 12-byte for using a secure random instance. After that, we create a GCM parameter spec object, which tells our cipher about the for and the tag length. Next, we initialize the cipher in encryption mode and provide the associated data. The final step is to perform the encryption, and we return the ciphertext concatenated with the for. This approach ensures that we have all necessary data to decrypt the message later. Now that we have our encryption method, let's implement the decryption method, which will reverse our process. It needs to extract the for from the beginning of the ciphertext and use it during decryption. In the decrypt method, we extract the for and the actual ciphertext from the combined input. We then initialize the cipher for decryption, providing it the for and the associated data, just as we did for encryption. Finally, we call doFinal on the ciphertext, which will return our original plaintext. Let's take a moment to see how we can put all of this together. We will create a simple main method that demonstrates the encryption and decryption process. This will allow us to verify that everything works correctly. In the main method, we define a sample plaintext, associated data, and generate our AES key. We then call our encrypt method to encrypt the plaintext, and after that, we call decrypt to return it back to the original. Let's run this code to see our GCM mode in action. When you execute the code, the output should display an encrypted byte array and the original plaintext, confirming that our encryption and decryption processes are functioning correctly. Now that we have the basics of GCM mode working, let's touch upon some security considerations. Using a unique for every encryption is crucial, as reusing IVs can lead to serious vulnerabilities. Always ensure the for is randomly generated and is never reused with the same key. Moreover, always use a secure method to handle your secret keys. Hard-coding keys in the source code, as we did here for simplicity, is not recommended for production environments. Consider using secure vaults or environment variables for storing sensitive information. To sum up, we have covered using GCM mode for authenticated encryption in Java. We discussed its benefits, implemented encryption and decryption methods, and ran a full example. GCM mode is a powerful tool for any developer looking to ensure the security of their data. Thank you for joining me today. If you learned something new, please hit the like button, subscribe to my channel, and share this video with your peers. Don't hesitate to comment if you have questions or topics you would like to see covered in future videos. Until next time, happy coding!